again. All right, Dr. Mashburn here. And so in this portion of the lecture, we want to talk about hormonal regulation. And so you've learned about the endocrine system. And so the endocrine system and the reproductive system are closely knit. You've got to have hormonal interaction in order for the reproductive system to function normally. And so we want to talk specifically about hormones and male hormones and how they work in the male, specifically testosterone. And this is not too complicated. You've already had your endocrine lectures, so hopefully this will make a lot of sense. It's not as complicated as the female. Okay, so we will talk about the male now and then the female a little later. When we talk about the male reproductive system, you've got to go back and think about the endocrine system and the hypothalamus and the pituitary gland. And so you have to remember that it's more than just the testes that are involved. It's not just testosterone from the testes. You have to have the role of the hypothalamus and the pituitary. And we call that the hypothalamic pituitary gonadal axis, or HPG axis. Okay, so it's the sequence of regulatory events, these hormonal regulatory events that involve the hypothalamus, the anterior pituitary, not the posterior, but the anterior pituitary, and the testes. And this axis regulates the production of the gamete, of the sperm, and the production of sex hormones. And it does it through a set of hormones. You have one of them is GnRH. Okay, so it's three sets of hormones. GnRH will indirectly stimulate the testes via FSH and LH. So GnRH from the hypothalamus, FSH from the anterior pituitary, which are going to stimulate the testes, and then the testes are going to make testosterone and inhibin. So hypothalamus, anterior pituitary, and testis. Okay, and this is going to be a negative feedback mechanism as well. So let's give you a schematic and let you see how that looks. So get your anatomy and think about what's happening. So you have your hypothalamus, all right, and it releases hormones. So remember, when the hypothalamus makes inhibiting and releasing hormones, right? So it makes a releasing hormone called gonadotropin releasing hormone, GnRH, and it's released into the blood. Remember, there's a capillary system, okay, that connects the hypothalamus and the anterior pituitary. Don't get confused. Remember, the posterior pituitary, it just stores hormones that are made by the hypothalamus. So this is GnRH secreted into those capillaries to the anterior pituitary. That stimulates, because it's GnRH, gonadotropin releasing hormone, that causes the anterior pituitary to release FSH, follicle stimulating hormone, and LH, luteinizing hormone. Those enter into the bloodstream, all right, and they travel throughout the body till they get to their target. And the target is going to be in the testis. All right, so we're going to talk about what each hormone does, because they both have a role to play in the production of sperm. All right. So FSH will cause cystinocytes. Cystinocytes are Sertoli cells. You may have seen that word as well when you looked at your anatomy. If you haven't watched your anatomy, you need to go back and watch our your anatomy videos, because that will help you with the male reproductive system. But we're talking about inside the testes, in those seminiferous tubules, where you have those cystinocytes. I can't talk today. Cystinocytes, which help the sperm undergo their mitosis and meiosis stages, or meiosis stages, where you're going to get the development of the sperm. So if you haven't watched your spermatogenesis video, again, you should watch that as well. So you're going to get FSH binding to these cells and causing the release of something called ABP, or androgen binding protein. And what that does, androgen binding, so testosterone is an androgen, it binds it, it keeps it around. It helps keep a high concentration of testosterone near these cells. And that plays a role in spermatogenesis. So it allows this area to be bathed in testosterone so that you can get the development of these sperm. That's what FSH does. So it goes down to the testis, causes the release of ABP, which keeps doesn't make testosterone. It just keeps testosterone around so that spermatogenesis can occur. All right. Now LH, what it does, it goes also to the testis, but a different cell. It goes to these interstitial endocrine cells, and it causes them to produce testosterone. So this is where the testosterone is made. So the testosterone is made by these interstitial endocrine cells. Okay, the FSH causes testosterone to hang around, and then together you get spermatogenesis. Okay. What else you get is some of this testosterone, all right, that's not going to act locally, will act as a hormone throughout the body. So some of the testosterone acts locally for the spermatogenesis. The rest of the testosterone goes out into the system, goes to other targets like bone and muscle. And so you're going to get your secondary sex characteristics like increased body hair, deeper voice, all those things that make, that we talked about being male secondary sex characteristics is going to be another effect of this testosterone. Now, depending on the level of testosterone and the level of FSH, you're going to have a negative feedback loop, all right? So high levels, rising levels of testosterone are going to go and feed back and have negative feedback inhibition on the hypothalamus and the anterior pituitary. All right, so the more testosterone you have, that's going to go back and negatively feed back on those two organs and shut those down and decrease the amount of GnRH and FSH that's being released. So negative feedback. All right. On the flip side, the negative feedback also occurs in the presence of something called inhibin. And so inhibin is something that's released when sperm count is high. So if sperm count is up and you don't need to make any more, you'll get this compound called inhibin, and rising levels when inhibin will act as a hormone and go back to the GnRH, or go back to the hypothalamus and the anterior pituitary and inhibit them as well. So the more testosterone you have, the more sperm you may have, you'll have negative feedback. And this is important. This is one of those, I know sometimes my male students are really worried, you know, how long can you go between orgasm, between ejaculation? I mean, will sperm continue to be produced over and over again until the testis and the scrotum would explode? I've actually had this question. And no, because as sperm levels get high, you make inhibin, which kind of goes back and inhibits and slows down the production of FSH and LH, and that slows down spermatogenesis. So you're gonna maintain a homeostatic level of sperm production. It's also the reason, if you have a vasectomy, if you haven't thought about this, if you've cut the vas deferens or the ductus deferens, you're still going to get all the seminal fluid, so you can still have an ejaculation, there's just no sperm. So men who've had a vasectomy still make sperm. They're still producing sperm, but they finally reach an equilibrium due to this production of inhibin, so that they just make a certain amount of sperm. And those are simply resorbed into the body because they're not ejaculated. So no danger, guys, if you're worried about that. And it's a true fear. Someone asks me that every semester. So this HPG axis, it turns on at about puberty, and it takes about 3 years for it to become stable. So when boys first start to go through puberty, they're not particularly fertile. I mean, I wouldn't say they're sterile. Okay, so a young boy beginning puberty is making sperm and is quite fertile. But to reach your balance where your testosterone and sperm production are fairly stable, takes about 3 years, and then it maintains pretty constant throughout your lifespan. This is why men can continue to have children on up into their 70s, 80s, 90s, because they're going to continue to make sperm and testosterone. If you don't have GnRH and these gonadotropins, or to remind you, gonadotropins are FSH and LH. Without these, if something, for some reason, there's no release of GnRH and FSH and LH from the hypothalamus and pituitary, the testes will atrophy, and sperm and testosterone production will cease, and so therefore you will be sterile. So perhaps a head injury or some kind of a tumor that's affected the hypothalamus and the pituitary gland. So what is testosterone? It's made from cholesterol. It's a cholesterol-derived hormone. It's a steroid hormone. So if you think back to your endocrine system, I'm going to kind of put this on you. Where does that work? Where's the receptor? And so I'm not going to tell you, go back, but you need to know, is this one that crosses the membrane and binds inside, or just one that binds to the membrane? So what's it doing? So go back and look. What does steroid hormones do? All right, that's on you. All right, testosterone is made by the testes, but it's also made by the adrenal glands. So don't forget, the adrenal glands make androgens. You should have already learned this as well in your endocrine system. And so even though you do make androgens in the adrenal gland, it's not enough to maintain normal levels of testosterone that you need for sperm production. Okay, so you do have this. It's women have testosterone from adrenal gland production, but just not sufficient to counteract the effects of estrogen and progesterone. What does testosterone do? Remember, you're going to start developing and producing testosterone early in fetal development, and it will masculinize the embryonic brain. Some people say that's men tend to be more aggressive, and that can be the effects of testosterone. And so these effects go well into adulthood. So more aggressive, and I'm not saying mean or violent, I'm just saying kind of that more aggressive attitude is sometimes contributed to testosterone. It promotes spermatogenesis, it targets the other accessory organs, has multiple anabolic effects, so muscle growth, bone growth, things like that. So anabolism is to grow, to increase in size. If you don't have enough testosterone, you have atrophy and semen volume declines, and problems with erection and ejaculation. And so very common, men with low testosterone levels can take testosterone replacements, and that can help with these symptoms of low testosterone levels. Maybe you've reached your 20s and 30s and you're ready to start a family, and you find out that you're not fertile, you're sterile, and maybe a low testosterone level. And so testosterone injections, or they have a patch now, a cream, can help with this fertility issue. All right, so remember we have those secondary sex characteristics, and these are things that are induced by testosterone. So again, you're going to get the appearance of hair, pubic hair, axillary hair, facial hair, growth of hair on the chest, deepening of the voice, skin becomes oily and thick, bones grow, get more dense, muscles increase in size and mass. You have a boost in metabolic rate. This is when those teenage boys, they can eat 4 or 5 pizzas and still be hungry. So they seem like they eat all the time and never gain weight. That is a definite positive of testosterone. And it's the basis of their sex drive. So libido is due to the testosterone levels. So again, a male in their 20s or 30s, ready to start a family, maybe sterile, may have low sex drive. And so again, those testosterone remedies can help alleviate that as well. This is just a kind of a cool schematic showing you the changes in testosterone levels through your lifespan. So this is fertilization, so at conception through birth. And you'll see in the male, you're going to see an increase in testosterone levels. Okay, so this is going to be that masculinization of the fetus. Okay, so we'll talk about the X and XY and male and female development, but this presence of testosterone kind of, helps masculinize the male fetus, and it'll increase till about 3 or 4 months, and then it drops. Then it kind of drops down. So this is kind of when you're setting down the path of maleness, and then once that's established, the levels go down. Basically, is kind of how you can think about that. And then right after birth, somewhere within the first couple of months, you may see a spike in testosterone levels. And this is sometimes seen, moms sometimes notice their little boys, maybe the scrotum looks really large, and so maybe, and that's because of this spike in testosterone levels at just after birth. There's a kind of a natural surge, and sometimes you'll see a little bit of an enlargement in the external genitalia, but don't worry, it just kind of goes back down after a few days. And then it just kind of levels off. And so from 4 or 5 months all the way up to 10, 11, 12 years old, testosterone levels are really low and stable. You're getting that from your adrenal gland, and there's just not a whole lot going on. If you look at young boys and young girls, they look the same. I mean, there's a lot of things that look very similar about males and females. And then they hit puberty, and now these secondary sexual characteristics, secondary sexual characteristics start to show up. And so at puberty, you're going to get this spike in testosterone. So you're going to have the growth spurt, the deepening of the voice, the bigger muscles, bigger bone mass. Then it peaks. And so somewhere around 18 to 20, it peaks, and it remains pretty stable for a long, long time, well into your 70s. Okay, 70s and 80s, you're going to maintain this level of testosterone. And then, past 80, those levels will start to drop. So although there are some fathers out there who are in their 80s, 90s, and 100s, it does become harder and harder and less likely because you do start to have a natural fall in testosterone levels at end of life. But here from about 18 to 75, everything's pretty stable and perfectly capable of producing sperm and becoming a father. All right, so I think that's all I'm going to talk about now. We'll continue with some more videos, and I appreciate your attention as always. Thank you.